Assalamu alaikum, girls.
Walaikum assalam, Miss. How are you?
Alhamdulillah, I'm fine. And a very good morning to all of you.
Same to you, Miss.
Yeah. Are you ready for the class?
Yes,
Yes.
Good. In fact, it's really good to see you all.
Miss, we're reading this new chapter, right?
Yes. Okay. Now, girls, I hope you remember last week I have given you the lesson 5 notes. I hope you have already written in your record book that note that I gave you.
And why did you give so much?
No, dear, it was 3 page, dear. It was
It
only
was
3.
5 page.
No.
Yes.
Yeah,
It
but
was
it is.
5.
Yeah, I know. Because if you have all those, so that I can easily explain to you this week, because I have 2 class in this week. I can finish this lesson. And you know, after this, we have another lesson that will be a kind of big lesson, lesson 6. And then our syllabus will be over.
Miss,
Yes, dear.
if this pandemic stops and our school opens, would you take my copy from my assessment portion?
That's a funny question. Okay. Inshallah. Let's see. Just
Would you
pray.
take from?
No, it
would
was
you?
kind of funny, dear Amira, that I had a huge time with you in the school. You didn't submit your copy that time, and now
No,
you're.
Miss, I did. No, Miss, I did. I made a
Then
new copy.
what? Okay. Oh, it's a new copy.
Miss, my old copy, it was made of plastic and it wouldn't last 3 years.
Okay.
So my mom suggested that I make a new copy. Then I
Okay.
thought that I know you won't check from the first semester, so I just wrote the assessment portion and the midterm portion. I mean,
Okay.
final term portion.
Final term portion. Okay, fine, no problem. If the school reopen, inshallah, I'll do it.
I know it will be too much for you for the first semester.
No, but that is already marked, so I can just put a tick and put my signature.
Yes,
The next
so
one I
you don't
will
need
check.
to check it. I will
Yeah,
just
I
write it
know.
in my copy.
I know. Okay, dear, inshallah, no problem. Just pray so that all this situation is over for us and all of us can have a normal life the way we used to have before, right, girls?
I just thought you would get angry and
No, dear, why will I? You're my
because
student.
it's a lot of work.
I have to understand the situation here. Okay, fine. So, girls, now just tell me one thing. I hope all of you have finished learning lesson 4. Did you find any difficulty? Because I'm going to start lesson 5 today. Anyone having any doubt in lesson 4? You can
No, Miss, but I was like learning lesson 5 and I had doubt on that.
Definitely. I didn't explain to you there. I will be doing it today, inshallah. And now, tell me one more thing, girls. I hope all of you are in good health. Are you taking care of yourself?
Yes,
Miss.
Miss.
Alhamdulillah.
Yes. Very
Miss, are
good.
you?
Yes, yeah, alhamdulillah, I'm fine. Because you know, you learn so many things. Right now, it's kind of very hot here, right? Last 2 days, it's getting really
Yes,
hot.
Miss.
Summer is really high on us now. So, but you have to be very careful. Please, girls, don't drink lots of cold water, lots of cold drinks. No. Okay, make sure of it because you heard about so many things regarding this COVID and all, right? So we need to be careful and taking care of ourselves. Okay, guys, because I know some of you do have a habit of switching on the AC the whole night, drinking cold water and all this. So try to maintain it because you're big enough and you can understand the situation and you can read out on the net also that how we can keep ourselves safe from this disaster that is happening around the world. You saw, right, what is happening in Europe, Italy, Spain, France, and USA. Latest, US is the worst place for this COVID now, right? So let us, all of us, keep ourselves safe and pray for all of us. Because we always hope that this thing will be over and we'll all go back to our normal life. Right, girls?
Yes.
Inshallah. So let's start our lesson today. It's about
Miss, I had a question.
Yes, dear. Yes.
If we take printout of...
Could you say again, dear? I couldn't hear you.
If we take the printout of the notes you send in the WhatsApp group,
I
then
think, no, dear. No, I think you should write it yourself because those are my handwriting, right? It was not typed. So if it was typed, you couldn't. You could take the printer. But I want you to write it in your own copybook. You have enough time, right, dear? No, dear. You have to do it like this. Okay. Now do one thing, all of you. mute your mic so that I can start my class. When you have a doubt, then only you can ask me a question. Okay, class? Otherwise, it's making noise. Yes, please, all of you. Okay, now let's start, girls. As I said, today we are going to start lesson 5. And this is about liquids and vapor. If we just check these two words, liquid and vapor, we can understand it is actually about two states of matter. We learned solid, liquid, gas. So liquid, we can understand it is a state of matter, and vapor, that will be the next step of vapor. Vapor is the next stage of another like a state, the one we call three states of matter. So when will liquid turn into a vapor? We know that when we apply heat to liquid, then it will make some changes inside it. Means that time the intermolecular force will be more. They will push the liquid molecules away from each other. They will break free and they will become gas. This one we learn again. We have another chapter that is called latent heat. That is nothing but the change of state. There we'll be learning it again, but at this moment I want to tell you that liquids and vapors, this is the part where we're going to learn two process of changing the state here. One is called evaporation, another one will be known as boiling. In both the cases we'll see that the liquid will turn into gas. So it's the change of state. Now first we are going to learn evaporation. It is a process you need to remember that you don't need to apply any heat energy from outside. From the surroundings, this particular situation, evaporation, is going to happen when it is going to gain the energy from the surroundings, and then it will turn into gas molecule. Liquid itself will turn into a gas molecule. So we say that when a liquid changes into a gas without reaching the boiling point is called evaporation. Now let me remind you, each and every liquid do have their own boiling point. Like we know that water has a boiling point of 100 degrees Celsius. Like that any other liquid, alcohol is having a boiling point, then oil is having a boiling point. Each and every molecule every liquid is having its boiling point. But we are saying that when a liquid is going to change into gas without reaching the boiling point, means it can happen at any temperature. No matter whatever the temperature is, it can happen there. Means liquid can become gas molecule. Without thinking about the boiling temperature, we'll remember at any temperature when liquid turns into gas, we call it nothing but an evaporation procedure. Okay. Now, why they are getting evaporated means why these liquid molecules are turning into gas molecules. We have to understand that. That is, liquid evaporates because some of the particles move faster than the others. We know that if you just keep a certain amount of liquid in a container, in a small bowl, then you will see some amount of liquid is there. Just imagine today you kept a small amount of water inside a bowl on your table. After 3 days, if you just check, you will see that either there will be no more water there or there can be less amount of water. So why it happened like this? We know that the temperature on your table, when you kept it on your table, can never be 100 degrees Celsius, for sure. Second thing is that here some of the liquid molecule or water molecule already got evaporated and it became water vapor and moved around the air that is present in that particular room. So it is happening in certain processes, means the molecules which escape from the liquid do have an energy which is more than the other. We call them moving faster. And we know that the formula of kinetic energy is half mv square. So v is nothing but the velocity. So these molecules do take energy from the surrounding molecules and overcome the force of attraction between the molecules. Because when we keep some amount of liquid, all the molecules do have this energy which is working in between the molecules. So they overcome this amount of energy and evaporate to the surroundings. So we call that the faster moving molecules which have enough energy to overcome the force of attraction of each molecules are constantly escaping from the liquid surface. This surface word is so important. Excuse me, guys. They say that all the time this evaporation happens from the surface. If a molecule is having more energy, it is going to come up, it will pop up to the surface, and from the surface it will get evaporated. So later we'll be saying that evaporation is a surface effect. Any molecule from inside the liquid cannot evaporate. It has to come out to the surface or come up to the surface. From there, it can escape as a gas molecule. So this surface word is very important to us. Okay, guys. Now, let's consider which are the situation and what are the reasons we have in our surroundings that makes the liquid evaporate faster. Okay, this is a very important topic you will see in the exam paper. So many times they will give us this point to write down that what are the things that can be done which will increase the amount of evaporation or which will increase the percentage of evaporation of a liquid. Okay, so what are those? Number one, increase in temperature. Now let me remind you, if it is winter, definitely the room temperature or the temperature of the surroundings will be much lower than now. Now it is summer, so at this moment right now it can be the temperature around 25 to 28 degrees Celsius. So this 28 degrees Celsius temperature is going to increase the process of evaporation rather than when the temperature was at 12 degree or 10 degree. Okay, so this is why we are saying that if the temperature in the surroundings is going to increase, then it will increase the evaporation process. And what is that? Increase in temperature, like I wrote. Increase in temperature, like I wrote. This makes the molecules move faster due to their higher average kinetic energy, and therefore more of the molecules have enough energy to escape from the liquid. It means, as I said before, if the temperature in the surrounding place of the liquid is increasing, we can expect that the evaporation process will also increase. More number of liquid molecules will get evaporated due to the temperature rise. So this is point number one. Point number two, increase in surface area. Okay, I want to give you a small example. Just imagine you kept a half glass of water in your table. So it might take 5, 6, 7 days to evaporate all the water molecules. But if you just spread the water on your table, within 2 to 3 hours, you will not see any more water molecule on your table. Because when you are dropping the water on your table, it's going to spread over a huge area. That will make more water molecules to get exposed to the air, and they will just get evaporated faster than when the water was inside the glass. Like I gave you another more example in your note. Let's see that. This gives the faster liquid molecules a greater chance of escaping. There are more molecules at the liquid surface which can escape as gas molecules. As I said, more surface area, more water molecules are getting exposed to the air and it's getting evaporated. I gave you an example of, see, wet roads dry quickly because the rainwater is spread over a large surface area. If I collect that same amount of rainwater on a bucket, it will take at least 15 days to evaporate. But if I just spread it all over the road, then definitely within 2 hours, you'll not see any more water molecules on the road. So that's what we say, the more the surface area, the more the evaporation process. Girls, is it clear to you, the first 2 points? Hello, girls.
Yes, miss.
Very good. Let's proceed. The next one is decrease in humidity. Now, what is humidity? Let me just tell you. I think most of you knows about this one. But then also, that is, we know that when the presence of water molecules in air is known as humidity. So if the humidity is more, it cannot take more evaporated water molecules in its certain space, because every air has certain room for water molecules, evaporated water molecules. So if we can do something, that if we can decrease the humidity at a certain area, we can say that more evaporation will be there. But how is it possible? I will give you the example of Bangladesh or any other country where it rains a lot. So in the rainy season, if you just wash one of your clothes and allow it to dry in the open air, you might get that it takes almost 1 full day or 2 days to get it dry. But
it took 3 days.
Yeah, it can be as well. It depends on the amount of rain and it depends on the amount of humidity on the air. But just imagine if it was like winter, in the winter time, hardly it rains and there is less number of water molecules or humidity in the air. That time, if you just clean your dress and allow it to dry it in the open air, within 2 to 3 hours or after 4 hours, you'll get your dress completely dry because that time the number of water molecules in the air is less. So it will take more water molecules from the dress and it will make it dry faster. So when there is less amount of humidity present or percentage of humidity is less in the air, that time there's a chance that this evaporation process is going to be faster. Okay, or we can say decrease in humidity increases the evaporation process. Clear? Okay. Now let's come to another point number 4, that is blowing air across the liquid surface. Okay, now what is that? As I say, if you have, just imagine that you washed your dress and kept it in a place where it is enclosed air with a fence and there is no movement of air. Then also during the winter time, it will take at least 5 to 8 hours to dry. But if you allow it in an open area where the air is blowing and the cloth will dry within 2 hours. This is the point. It means that, you know, the water molecules that is getting evaporated will be immediately close to the particular wet cloth surrounding it. But if there is blow of air, it will take the water molecules of evaporated water molecules along with it. And new air will come, there will be new room for the water vapor. So it will take the water molecules from the dress or the cloth very faster. So that is why the evaporation process or this is getting dry process of this particular clothing will be faster. So we say when air moves across a liquid surface, it carries away escape water molecules and reduces their chance of returning to the air. Now I want to give a very easy and simple example. You know, we do mop our home, the floor. So what we do sometimes when we are doing it faster, we'll mop the floor and immediately we'll switch on the fan as well, so that it will quickly get dry. Isn't it? Did you notice, girls, that your mom does like that? Once in a while? She does like that, right?
Miss, could you repeat?
Okay, we say that when we are mopping our floor, after mopping, immediately we switch on the fan also, so that the water molecules on the floor will get dry faster and there should not be any chance of getting an accident or something. Sometimes we do slip, right, on the water. So that is why we are doing. Because a blow of air will increase the evaporation process of the water molecules that is present after mopping the floor. Is it clear, girls? Did you notice that these things are done at home? See, this is physics, but we don't know, right? We are doing every single day. Very good.
My mom does it often.
Very
Every day.
Yeah, even me does the same thing. I'm doing it every day. And nowadays, yeah, your small sister is there as well. And for me, nowadays, every single day I'm doing twice because cleanliness is a must for this all virus protection and all. Okay, fine. So this is physics that can help us to stay clean as well as in safe conditions.
And kill corona.
Yeah, yes, inshallah. Okay, guys. Now, let's go to the next topic. Okay, now let me remind you how this question is coming. They will be asking you the question like this, that what are the processes can be done to increase the evaporation process? Okay, so you'll be just, you'll see when I'll be solving the past paper questions with you. Only from this particular topic, the 4 results that I discussed with you, there was a question of 4 to 5 marks only from this topic. So you can understand this topic is so important to us, okay, because it relates very much to our daily life procedure, what we are doing in our life. Okay, guys. Let's go to the other procedure. As I say, boiling. This is another method of making liquid to gas. Change of state is happening here. We are going to apply heat. If you remember a few minutes before when I was explaining to you the evaporation, we say that we are not going to apply any thermal energy, but the energy will be taken from the surroundings. But here, boiling means we are going to apply heat energy to the liquid. And the liquid will reach to its boiling point, and then if you keep on applying the thermal energy, it will turn into gas molecule. This procedure is known as boiling. And let me read out the definition. When a liquid reaches a particular temperature where it expands, means we know that when you apply heat, whether it is a liquid, solid or gas, it will increase in volume. So I use the word where it expands, rises, because when it is expanding, it has to rise, bursts and releases large amount of vapor is called boil. But this whole thing never happens in case of evaporation, because evaporation is a very slow process. 1-2 molecules is running away or escaping from the liquid. So this type of huge vigorous movement we can't see. But in water, when you are boiling it in a pot, you place it on the burner and you'll check when boiling is happening, you can see a huge movement inside the water. Like a bursting thing is going on. The water molecules you can see from the bottom is going up and from the top it is going down. A huge movement inside the water is happening, like this. And you can see huge amount of vapor is coming up. So this is a process where the liquid gets expand fast, temperature rises, and when it reaches to 100 degrees Celsius, if we take water, and then it rises, bursts, and releases a large amount of vapor. We call that process as boiling. Okay. Now the next topic is differences between boiling and evaporation. And if you just take the paper 4, you'll find that so many times this particular question. Write down the 2 difference, write down 3 difference. Mostly they will ask for you to write 2 differences between the boiling and evaporation. So you'll read out and learn this table very carefully. And one more thing I need to tell you guys. If you just look at the bottom of this table, the 3 points like 4, 5, 6, these points are very small. So whenever a difference is asked for, I want you to always write down point number 1, 2, 3. These 3 points are very important. You know, some things are there that some are very important points, some are less important points. So whenever a difference is asked, we'll be writing always the very important points. Okay, guys. So let's read out. Boiling, I wrote, it occurs at a definite temperature. As I say, if you consider water, it will be 100 degrees Celsius. Now, take on the other side, I wrote for evaporation, it occurs at any temperature. As I said, it can happen at 5 degrees Celsius when it is winter, at the same time 40 degrees Celsius when it is huge summer, right? In both the cases, it is possible. But boiling will be happening for water only at 100 degrees Celsius. We cannot have any other temperature for this one. Okay. Point number 2. All the liquid molecules have enough energy to become gas molecules. Means in case of boiling, as the temperature of the whole water of the liquid itself reaches to a certain point. If you consider water, then all the molecules have the same temperature, 100 degrees Celsius, so they all have the chance to become gas, because all of them are going to have the same energy. But in case of evaporation, only the molecules with high energy at the surface of the liquid can become gas. See, this point is so important, I told you, surface. Because in evaporation, if a liquid is having more thermal energy, then only it can come up to the surface. And from the surface, it can overcome the intermolecular forces or intermolecular bond, and it will get become a gas molecule. So it is the process of evaporation that is happening. But for others, it is not possible. It means for boiling, it is not possible. In evaporation, if a molecule is at the bottom of the container, it cannot expect itself to become a gas molecule. Okay? Now, point number 3. Number 2 and 3 is very close, because in 3 we say it occurs throughout the liquid. Okay, it occurs throughout the liquid. It means that when we are going for the boiling, all the molecules do have the same energy, and there is a chance the molecule which is at the bottom of the container can also become gas molecule. But in case of evaporation, it happens only from the surface. So we say it occurs only at the surface. It's a surface effect. Means in short, we can say it is a surface effect. Okay. Now number 4. Look at that. Source of heat energy is required. We need a burner or a Bunsen burner, a lamp or a burner. We need some energy to be applied to it. Heat energy is needed. But in case of evaporation, energy is supplied by the surroundings. Means it can happen, there can be a blow of wind, there can be less humidity in the air, there can be the temperature of the particular day is higher. These situations can be happening in case of evaporation. That time the evaporation process will be increasing, okay, or the percentage of evaporation will increase. Okay. Now the next part I said, it is a rapid process. And on the other side, number 5, I'm saying it is a slow process. Definitely, If you want to evaporate certain amount of liquid or water, then you can just put it on a, take it on a pot and put it on a Bunsen burner or a burner and then apply it. So within few minutes, it will be all evaporated. But the same thing can be done with evaporation. It will take long time. So it's a slow process. Now, point number 6, I wrote no cooling effect, and in evaporation, I wrote have cooling effect. What is that? I'll explain to you later, but you just remember boiling do not show any cooling effect. Evaporation shows cooling effect. Now, what is this cooling effect? I'll be explaining to you in my next topic. Okay. Before that, guys, tell me the differences and boiling and evaporation that we discussed. Do you have any doubt regarding understanding this topic? Yes, girls. Anyone? Do you have any doubt?
No, miss.
No.
Very good. So I can proceed to the next topic, that is cooling effect of evaporation. Okay. As I say that this is a particular property that is shown by the evaporation, not by the boiling. So what is that? First of all, I'll ask you one daily life experience. In the school, remember during the break time you used to play, most of you used to play a lot. So after playing in the summertime, when you come inside the classroom, you immediately switch on the AC and the fan, and after that, how do you feel after 2 minutes? Do you feel good? Because when you are playing outside and coming back to the class after the break time, you are really feeling really hot and you are sweating, right? Like this, girl, isn't it? During the summertime, especially.
Yes, miss.
Yes, fine. So when we are coming inside the class and switching on the AC and the fan, after a few minutes you feel comfortable, isn't it? And you feel cool. You don't feel warm anymore because we need to say that all this sweat, which are nothing but water molecules along with some salt that is coming out from our skin, from our body when we are playing and getting exhausted, that water molecules of the sweating is actually getting evaporated from your body. But to get evaporated, they need certain amount of thermal energy. So they take the thermal energy from your skin and body and they get evaporated. So what happens? They take the thermal energy from your body and gets evaporated to the surroundings. Then what happens to your body, skin and all? It gets, drops to a lower temperature. Means you feel cool and you feel much better than before. And this is happening because of two things. Because you switched on the AC as well as the fan. Because fan, we say blow of air increases the evaporation process. At the same time, AC is giving us the cold air. That will also makes us comfortable. So the first thing is that if you don't switch on the AC also, only the fan can make you comfortable. Because the way the fan is moving, it will create a movement of air inside the room, which will allow more water molecules from the sweat of your body to get evaporated, leaving you cool and comfortable. Is it clear now, girls? Okay. Shahnara, what happened here? Okay, rest of the girls, could you hear me loud and clear?
Yes.
Okay, I don't know.
Miss.
Okay, I don't know, Shahnara. Could you
Miss.
just check there your connection and all? The rest can hear me, guys. Okay, fine. Even though I will speak loudly. Okay, hope it will be over now. Now, guys, let's go for the next point. Okay, the point I was explaining to you. Let me read out what I wrote there. Evaporation has a cooling effect. A liquid needs latent heat. Now, this latent heat word will not be that clear to you at this moment. As I said, we have the last lesson, lesson 6. We discussed a lot about latent heat to evaporate. Okay. So now let me just tell you what is this? It is a certain amount of heat given to a particular substance to go to the next state of matter. Like you have to have this amount of thermal energy to liquid, give to liquid so that the liquid can become gas. So we call that one as the latent heat. Okay. So after evaporation, the liquid and the object in contact with the liquid loses thermal energy. As I told you that when your body, from your body, when the sweat is getting evaporated, so the sweat means the water molecules are taking thermal energy from your body and it is getting evaporated. Very good. So when it is getting evaporated, it takes thermal energy from your body and your body stays with a lower temperature. That makes you feel comfortable and soothing. Okay, guys? Now, let us go for the next topic, the one we'll be writing in the past paper for 2-3 marks. Most of the time it comes for that amount of marks. That is cooling effect of evaporation and kinetic theory. Now, if you remember, when we started studying thermal energy, thermal physics this term, I told you initially the first topic for us was kinetic theory. And I told you whenever we discuss something, we'll just try to refer with the kinetic theory. Now also we'll be doing. What is that? If the faster moving molecules escape from the liquid surface, that is nothing but evaporation, right girls? The average kinetic energy of the remaining molecule is reduced. Definitely because they became faster moving because they absorb the thermal energy from the surrounding molecules. So they become more energetic and they are getting evaporated or getting escaped to the surrounding and leaving behind all the other molecules with less kinetic energy. So we say, so the temperature of the liquid is less than before. So this is called cooling effect because okay, I'll give you another example. Okay, now if you just imagine that you kept just a bit of warm water in your table, in a glass, after a few minutes, you'll see that the warm water is not anymore warm. Here, two things happening. First of all, thermal energy from the hot glass of water is transferred to the air or the surrounding place in terms of radiation, convection. At the same time, some of the molecules is getting evaporated to the surroundings. So all these three is going to reduce the thermal energy of the water. So after a certain time, you'll see that the water is going to decrease in volume. At the same time, the temperature is going to reduce a lot than before. So this whole procedure is actually nothing but the evaporation effect or cooling effect of evaporation. Okay. So you'll remember whenever there's an evaporation process is going on, the temperature of the remaining liquid will be decreasing. So we call it as nothing but the cooling effect. Is it clear, girls?
Yes.
Okay, fine. Very good. Now let's go to the next topic. That is actually already I discussed with you. That is cooling effect and sweating. You'll see some questions will also be. Okay, guys. I want to give you an example. You might have seen on television that sometimes when they show us the Olympic marathon and all these race, did you notice that because you know that marathon is a long race, it sometimes goes for 30 minutes to 1 hour. So when a person keeps on running for a long time, we discussed about covering them with a shiny blanket. Do you remember that? In my previous lesson, we discussed at the end
Yes,
of that. Yes, fine, very good. Now, here another thing that players are doing, or these runners are doing, you notice next time when you watch on television, you see they'll be holding a small fat bottle of water and they'll keep on pouring the water on their head and all over their body. And then keep on running because they cannot stop. That's the rule. They have to keep on running. And while running, they do like this. They pour the water on their head, on their hair, hair and all. They keep on making wet all their dress and all this. And they do it purposely because you know those when they're running they are exposed to the air, so these water molecules from their body will get evaporated leaving them cool, so they will be more comfortable to run for the next. Otherwise they keep on increasing their body temperature when they run due to the biological mechanism. Their body temperature goes higher, so to keep it cool and to keep it down they do it like this. That water molecules from their hair and their body gets evaporated, taking the thermal energy from the runner and keep them in a comfortable temperature. So that helps them to complete the race. So this is one thing they do. So we are not writing that part here like this. Sweating uses the cooling effect of evaporation while sweating. Okay, how? The body temperature rises above 0.5 degrees Celsius than normal. Means when we sweat, when you run, when you play, definitely our body temperature rises more than 0.5 degrees Celsius than normal. Means our body temperature is 37 degrees Celsius, everybody knows that. But when we run or do some physical exercise or even we work, that time it goes higher to 37.5 degrees Celsius. Then what happens? Our body starts sweating. When sweat evaporates, it takes thermal energy from the body and the body cools down. That is why that marathon runners are pouring water on their head so that they can become comfortable. On a very humid day, sweat cannot evaporate easily, so it becomes more uncomfortable. Means if it is a winter and there's less humidity on the air, immediately the body sweat is getting evaporated. So the person will not be feeling bad about it. It will be comfortable for him. But when it is a rainy day, huge amount of humidity on the air, or it is beside a sea place somewhere, like over here we have Jeddah, in Bangladesh we have Cox's Bazar, or any other place, the seaside uh, places, mean the seaside cities, they do have a higher humidity in the air all the time. So in those places, it is really uncomfortable because the doesn't get evaporated fast. So they feel uncomfortable. Okay, fine. Girls, now tell me, do you have any doubt regarding this cooling effect of evaporation that I discussed with you? Any questions?
No.
Okay, fine. So it's clear, right, Mahmuda? How are you? Mahmuda, are you there?
Yeah, fine, Miss Bella.
Alhamdulillah. So did you write all the notes in your copybook?
Yes.
Good. Inshallah, after this 2 videos, we'll be checking. Okay. Now, I want to go to the next topic, that is melting point. And
can you explain again?
which one, dear Shanara?
Cooling effect.
What is cooling effect? That one only? Okay, fine. Let's do it. First, as I say, when evaporation occurs, actually, what is evaporation? Evaporation is a process where liquid becomes gas without reaching its boiling point. So, as I say, that whenever some of the water molecules gain more thermal energy or more energy, we call them more energetic molecules. When they get more energy, and how will they get? Because we are not applying any heat energy to it, they will get them extra energy from the surrounding molecules. And think about one of the molecules absorb the energy from the surrounding molecules and it gets more energetic. It comes to the surface of the liquid and gets evaporated. So when they get evaporated, that time we say that this evaporating molecule actually took the thermal energy from the surrounding molecules, leaving the rest of the molecules in a lower thermal state. Means the rest of the molecules are going to have a lower thermal energy that make them cool down. So this is called the cooling effect. Whenever evaporation will be there, the volume of the liquid will decrease definitely because the some of the molecules will get evaporated. And the rest of the molecule will come down to a lower thermal state. The temperature of the average or the average kinetic energy of the rest of the molecules will decrease. That will make the temperature of the liquid go down. At least 2 degrees Celsius, definitely. It depends on the amount of evaporation that has occurred there. Okay, is it clear now, Shanara? I hope it is clear for her. Okay.
Yes, Miss.
Very good. Okay, now Afsana, Maha, do you have any doubt there? Are you following my class? Maha, are you there?
Yes, miss. I don't have any doubt now.
Okay, fine. Is it clear, the one we discussed today?
Yes, miss.
Very good. Okay, fine. So I want to go to the next topic, that is melting point and boiling point. Now, if we just read the 2 words that I wrote, melting and boiling. Okay, these 2 words actually leads us to a change of state. Okay, melting means definitely there has to be a solid. It will turn into a liquid. So it's a change of state. And boiling means liquid will turn into gas. So again, change of state. Okay. And we are saying these 2 should have a certain temperature, like melting point and boiling point, a particular temperature for a particular liquid or a particular solid. Now, if I ask you a question, that what is the melting point of ice? Because ice will turn into liquid, means ice will turn into water. So what will be the melting point of ice? Because
0 degrees Celsius.
very good, 0 degrees Celsius. At the same time, we call the same temperature as nothing but the freezing point. Because at the same temperature, the water turns into a solid. So that time it becomes ice, water to ice or ice to water, the same point. Okay. Now, if I come to the boiling point, the same thing happens over here also. If I consider water. Welcome back, girls. Could you hear me? Hello, girls.
Miss.
Welcome back. So I will be.
Miss, are you going to upload the next notes today?
Which one, dear? No, today I will not give you any note. Lesson 5 is over. I have given you the note in my previous week. Today I'll discuss it. Then we'll do the past paper regarding these questions. After that, we'll go to the lesson 6. Okay. So now I was in a melting point and boiling point. That topic. Okay, guys. Let's do this. The temperature at which the solid melts to become a liquid is called melting point. The melting point of ice is 0 degrees Celsius. This is a very common example we give all the time. The temperature at which a liquid becomes gas is called the boiling point. The boiling point of pure water is 100 degrees. So I hope in this particular point we don't have any doubt, right, guys? Okay. Now let's take the other part. Then I wrote condensation and solidification. Okay, condensation and solidification. If we just take this point, first of all, condensation, this word is also another change of state. Here from gas, it will turn into liquid again. We call it a condensation. And since you are studying chemistry, you might have learned a lot about this condensation in chemistry. Here we are going to discuss again. Okay. Now, one more thing I need to tell you regarding solidification. In solidification, we say one more thing, that is, it is from liquid to solid. We call it solidification. Okay. I want to give you a simple example. Think about on a small pot, you have taken some ice and some water and a few spoons of sugar. You placed it on it. And you try to mix it, and after a few seconds or few minutes, you see the sugar will be getting melted inside the water. After that, put it on a burner and apply heat to it. You keep on applying heat. After a certain time, you see that the water is evaporating, and then you see the small crystals of sugar is going to form over there one more time. So we call it solidification. We first of all we melted it inside water, and we actually dissolved the sugar inside water. Then again evaporated the water to get the sugar in the crystal form again. So this is solidification we did from liquid to solid turn. But in condensation also we can do the same. When it is evaporated water molecules, we can turn them into liquid. So this is from two change of state that is going to happen in terms of these two methods. So let us start with condensation. Condensation is when a gas changes to a liquid and latent heat of vaporization is released. Now guys, let me tell you one more thing here. This latent heat of vaporization I'm going to teach you in my next lesson, but right now you'll remember latent heat of vaporization. Before I told you what is this latent heat, it is the amount of heat needed to change a state. We'll again discuss a lot about it in the last lesson, but since it is referring to that, we need to explain you a little bit so that you can catch up with it. Okay, so as I said, what is this? It is the heat needed to change the state of the substance, whether it is solid, liquid, or gas. Here we can say it was gas. From the gas, we're turning it into liquid. So what we are doing, we say that a certain amount of latent heat of vaporization is released. Okay, now why it is releasing? You will remember when it is at a higher temperature, it will release and come down to a lower temperature. Because when it is a vapor, if you think about water vapor, then you can consider it is in a high state or higher temperature state. From there, that status onwards, we have to cool it down to become water. So while we are cooling it down, we can say that actually some heat energy has to be released from here so that it will cool down and it will turn itself into a change of state to liquid, from gas to liquid. So we are saying as a gas loses heat energy, the molecules also lose kinetic energy and move slowly. Their intermolecular force of attraction becomes. Assalamu alaikum, sir. How are you? Girls, Mr. Salahuddin, our HOD of physics, is joining us. Say salam to sir.
Assalamu alaikum, sir.
Assalamu alaikum, sir.
Assalamualaikum, sir.
Assalamu alaikum, sir.
Okay, let's continue with our class. Okay. So I was telling you that whenever we have this change of state is happening to us, we say that we will in the condensation. As the gas is losing the heat energy, the molecules are also going to lose kinetic energy and they will start moving slowly. Their intermolecular force of attraction becomes more significant, pulling the molecules together and allowing them to form weak bonds until they form a liquid. As I told you. Yes, sir?
No, carry on, sorry.
Okay. Okay. So I was telling you that allowing, as we say, that when they're going to lose their thermal energy, they will lose their intermolecular, they will lose their energy itself, and the intermolecular force of attraction will become more significant so that they can come closer and form the next state of matter. And that is nothing but the liquid. Because it was at a higher thermal state, it came down to a lower thermal energy, and then they turned into a liquid. Okay. Now, just take the next paragraph that I gave to you. I said a common example of condensation is when over mirror steams up after a shower. Means when we take shower inside the washroom, sometimes you see that these mirrors are getting cloudy. Means you can't see yourself clearly. It means that there's some water molecules are going to form, the steams are going to form on the mirror. When a cold glass of water is placed on the table, means you took very cold water from the fridge and pour it in a glass and tuck it on the table. After some time, you see it also gets cloudy. So it doesn't mean that water molecules or water from the glass came out and collected on the glass. Sometimes what we do, we write our names, write just on the mirror, even on the window screen of the car also we do like that. During the rainy days, it happens like that. So we say that after a while, there will be a water droplets outside the glass, the water vapor in the air. Actually, the water from the glass did not come out. The air molecules surrounding the plates or the air that is surrounding the plates do contain some humidity, which is nothing but the water vapor. And the water vapors are going to start collecting by coming in touch with the cold glass, because they're going to lose thermal energy and they'll start collecting on the top of the glass. If you just move the glass from that place, you'll see a ring of water over there. Did you ever notice that, girls? Because it is our daily life experience, isn't it? Anyone? Did you ever notice that the cold glass of water gets cloudy when you keep it on the table?
Yes, miss.
Very
It
good.
happens all the time.
Yes, very true. But today you came to know that what is the reason behind it. Definitely, it's physics, nothing else.
I used to think it was from the water inside the.
Yes,
inside
you do have this wrong idea.
But
And
when I grew up,
yes, when you are studying physics, definitely you can explain all those situations in terms of physics, definitely. Okay, guys. Now let's take the next part that I wrote there. Oh, now we'll be going to solidification. Okay, guys. Now, I hope you don't have any more doubt regarding this condensation part. Right? It was about vapor turns into gas. Okay, now let's take, no, that was vapor turns into liquid. Yes. Now, solidification. As I said, liquid has to become solid. Solidification. So what is that? Is when a liquid changes to a solid and latent heat of fusion is released. Now, let me again tell you, these words will not be very clear to you at this moment. In the previous part, in condensation, I said latent heat of vaporization. Means it was a heat given to a liquid to become vapor. Now I'm saying latent heat of fusion. It is a liquid, it is the amount of heat given to a liquid to become solid. So now from solid I'm coming back to liquid, or from liquid I'm going to solid. So in that case, latent heat of fusion should be released. And as liquid loses energy, just like before we said, it's losing energy, the molecules also slow down and forms more intermolecular bonds with one another. They come closer. Because just I hope you corrected it. It will be they. I wrote the. They come closer. Okay, the white was missing here. They come closer together due to increasing intermolecular force, and thus they form a solid. So here the intermolecular force is increasing because from liquid it is turning into gas, turning into liquid, solid. So they are coming closer, The intermolecular force is increasing and they are forming a solid. Okay? Girls, any doubt you have here? See, we have finished this explanation today. So inshallah, I can do some past paper questions with you tomorrow. Right, girls? Now, you can ask me any question regarding this topic that you...
Just explain solidification again.
Solidification, no problem. I'll do it. So as I say, solidification is the process where a liquid is actually turning into a solid. A liquid is changing into a solid and the latent heat of fusion is released. Now, let me tell you, if I ask you right now that I want to make a piece of ice from a certain amount of water. So what will you do? Will you heat it or will you cool it?
Cool it.
Well, definitely. When you're cooling it, actually what you are doing, taking the thermal energy out of the liquid, out of the water. So we say releasing the thermal energy to the solid. So normally we cannot do that. We have to put it inside the refrigerator in the cooling compartment. Then it will cool in time and it will take time to cool down and it will turn into a solid that is a piece of ice. So thermal energy is released. That is why we say thermal energy which is released is known as the latent heat of fusion. The same amount of thermal energy you have to apply to the ice to make it water again. In both the cases, means liquid to water to ice, the amount of thermal energy which is taken out has to be given to the ice again to turn it into water. So you are taking out the thermal energy when you are making it ice and giving it to the ice to making it water again. So this is the procedure. And when you are taking the thermal energy out, then what happens to the molecule inside of it? We say that they are going to slow down. And definitely, when we are keeping the water on the table, it's the normal temperature, or you can say the water is at the room temperature. So the molecules are having their own movement. As we know that liquid molecules do move, sleep slide over each other, all this stuff is going on. So when you are keeping the same water inside the refrigerator, the temperature is cooling down. So these molecules will start moving slower than before, and they will come closer and they will form the intermolecular bond to each other. And then slowly, they'll increase the intermolecular forces and create the bond and they form a solid. So this is the procedure happens when you're taking the thermal energy away from the or out of the liquid in the cooling procedure, the one we call the cooling process. And then it turns into a solid. Isn't it interesting, girls?
Yes.
Okay. Now, as we are done with lesson 5, I told you it's a small one, but we have many questions in the past paper. Inshallah, I want to do it tomorrow, but today since we have few more minutes, around 5 to 6 minutes around hand, I want you to ask me any question that you have regarding this particular discussion that we have.
Can you explain condensation?
Solidification here. Maria, is it solidification?
No, Miss, condensation.
Condensation?
Yes, Miss.
Okay, let's do it again. Okay. First, you'll remember this thing. Condensation means, as we said, there are certain points that we say here: solidification, condensation, evaporation. They are the procedure that is followed by certain state of matter to go to the other state. Means it is all nothing but change of state. Okay. So condensation is also a change of state where a gas changes to liquid. Because we know that liquid can become gas, gas can also become liquid, vice versa. So this condensation is a procedure or is a process where a gas changes to liquid. And latent heat of vaporization is released. As I said before, when you want to turn liquid to gas, you have to apply heat to it. Because think about you took a certain amount of water, which was at a room temperature of 20 degrees Celsius. You have to put it on a burner and start heating it. You are applying heat to it. And then it turns into gas. So definitely, when you want to make that gas or that water vapor back to water, you have to take the thermal energy out from it. So we say that latent heat of vaporization is released. As the gas is losing the thermal energy, then what we have to say, the molecule will start moving slower than before. It will lose the thermal energy, lose the kinetic energy, and start moving slowly than before. Their intermolecular force of attraction become significant, it increases, bring them closer together, and they are going to form a weak bond that is found in a liquid. Slowly, they turn into a liquid. So gas is turning into a liquid. In this whole procedure and whole process will be known as condensation. Okay? Any doubt? Maria, is it clear for you now?
Yes, Miss.
Very good. So, anyone else having any doubt? Okay, if you don't have any doubt, I want to ask you a question first. Do you remember from which year I'm doing the past paper with you?
12 to 17, 18.
18 I suggested this time, yeah? Because all of you do have 2018 question. So inshallah, tomorrow I want you to keep it, and tonight we'll be just reading the whole note. If you can't learn, I don't mind, but make sure this week you're going to learn them. But today you read out so that you can have the note tomorrow in front of you and the first paper so that we can solve it together. But because I know tonight you cannot learn the whole thing, I'll give you time for that. But I want to keep the note in front of you and just go through it one more time. Then if you have any doubt in any particular thing that I wrote you can't understand, and just go through the textbook one more time as well. Just check whether you got any, you can get any extra information or some more information in the topic in your textbook. Go through the textbook one more time. And tomorrow, 12 onwards, I want to do the past paper test. I'll be selecting and telling you whichever question can be, because all the year we don't have the questions of this particular topic. We do have some of the questions, so I will be doing it. And then our last one will be, that is lesson 6, specific heat capacity and latent heat. Together, a big chapter. Okay, guys? So what do you think? Isn't it much easier for rather than general physics?
Yeah.
Yes, because in general physics we have lots of equations, lots of chapters, isn't it? Here it's not that many, right, girls? What do you say? Okay. I just want to ask you another thing, girls. I hope lesson 4 is fully done with you. You have learned.
Yes.
Very good. That's a good. Because girls, I want to remind you again, because you know that according to the school academic calendar, the school is supposed to reopen after the Idul Fitr, that is 7th of, no, I think around 1st of June or something. 7th of June it is scheduled our final exam. So if you consider that also, you have to be fully prepared for your final exam. Right, girls?
Miss, it's like 100 marks, right?
Actually, it is not finalized what is going to happen, but definitely, even if it is 100 mark also, we are going to make the question according to it, right? So that is why I'm doing the past paper as well as asking you to learn thoroughly so that you will be fully ready for the exam. Because we don't know at which time it's going to be open, but according to the exam schedule, we will be having that one in the 7th of June. So we should get ready for that. Okay, guys?
Miss, in our second term assessment exam, will there be any questions which will come from our first term portion?
No, dear, it's not. For you, it is only the thermal physics at this moment, yeah? No general physics question. Okay, guys, let's finish our class today. Inshallah, tomorrow I want you to get ready with the past paper and this particular lesson I want to read out. And tell me any doubt you have there. Okay, guys? Fine. Let's conclude my class today. All of you stay safe, stay well, and pray for all of us so that we can overcome this crisis of this world. Right, girls? Inshallah.
Yes.
Allah Hafiz. Assalamu alaikum, girls.
Alaikum assalam, miss.
Walaikum assalam.